Welcome to my second video in this chapter, Pure Mathematics 3 Differentiation. You'll find this in Pearson Edexcel Math by Mr. Kamotho as a YouTube channel. Please subscribe and share widely. In the previous video, video 1 in this topic, we had an arrangement that looked like this. And since I went a bit fast, I wanted to explain why sine of h over h is equals to 1 and why the cosine of h minus 1 over h is 0. And if you allow me, I will I will start with this one so that I can have a unit circle and a big circle for that matter so that we can have a good working space. That is the radius, which is also reflected here, and this radius is 1. The way we know, for us to talk about trigonometric ratios, we must talk about the opposite, the adjacent, and the hypotenuse, and therefore we must be talking about right angle triangle. This is the same thing that is also required when we are talking about the Pythagoras theorem. If we have a very small angle here, h, as you can see, the sine of h is opposite of a hypotenuse. And let's talk about the sine of h, which is opposite of a hypotenuse. But the opposite is this side, and the hypotenuse is 1. So if you cross multiply this one, you will find that the sine of h times 1 is exactly equals to the opposite. In other words, the opposite of this the opposite side, as far as this positioning of the angle is concerned, is given by the sine of h. So this is simply the sine of h. At the same time, you can talk about this side being the cosine of h, because again the cosine of h is adjacent of a hypotenuse, and since hypotenuse maintains to be 1, then this adjacent side is simply the cosine of h. Now I want us to consider, as h approaches 0, as h becomes very small, let us see what happens. But before there, we also know that if this is A and this is B, this arc is L, the arc AB, the arc AB, which we can call the arc L from here to here along the circumference, is always given by R, the radius, and times the angle in subtended at the center, RH. But because R is 1, then L is equals to H. That is interesting. When L is equals to H, we know very well that as now H becomes very small, just consider as H becomes very small. This is now the angle we are talking about. You can see there is going to be a perpendicular side which is 90, and also the L. There is the arc length, and there is the perpendicular side which was the sine h, and there was the L which was h. So as h becomes small, somewhere we cannot differentiate between this length, we are going to realize that the arc length will be covered by this perpendicular height of that triangle. So as h approaches 0, the sine of h, which is that perpendicular side, will be approaching the size of the arc length, which is the h. And at that point, the sine of h being equals to or approaching h, if you want to divide both sides by h, you realize that the sine of a very small angle divided by a very small angle will approach h over h, will approach 1. And that is why the whole of this part of our arrangement The whole of this part gave us 1. And 1 times the cosine of x is simply the cosine of x. That was that. And I think that is clear now why this part is 1 times the cosine of x. In a different explanation, let's have the same kind of another circle. I think that's a good circle. And let's have the radius, and let's have the radius now produced, so that we may have our right angle right there. And this is 1. And of course, let's talk about this being h. And you'll realize that the base is now 1 and the hypotenuse is now produced beyond the circumference of the circle. And I want us to talk about the tangent of h, which is opposite over adjacent. And the opposite is the opposite over adjacent, which happens to be 1. So the tangent of h happens to be the opposite side also. So if we can call this side the tangent of h, that is tan of h, then we will be right comfortable with that. That is the tangent of h. But I want us to compare the area. Can we now look at the area of the triangle versus the area of the sector of the sector? We could call this sector OAB, and the area of the triangle ABC. Fine. You can already see that the area of the triangle is obviously the area of the triangle of triangle A, or rather OBC, is given by a half times base, which is 1, times the perpendicular height, which is the tan of h. What about the area of the sector OAB? Area of sector OAB is given by what we know, a half r squared, and you can see the r is 1, half r squared times the angle in between h. And what is r? Our r is 1, so this is a half h. It is important to note that the area of the triangle is obviously greater than the area of the sector. And at that point, we can even say a half tan h is greater than a half h. The area of the triangle is greater than the area of the sector. Fine, if we multiply by 2 both sides, it follows that the tangent of h is greater than h. But what is the tangent of h? The tangent of h is the sine of h over the cosine of h. That we know. All right? The sine of h over the cosine of h is obviously greater than h. So if we divide both sides by h and multiply it by the cosine of h, then it follows that the sine of h over h greater than the cosine of h, greater than the cosine of h. And if you look at this, the sine of h over h, we had acquired it earlier on, where we said the sine of h over h for very small value of h is approaching 1. So in the same kind of explanation, the sine of h over h being equals to 1 is obviously greater than the cosine of h, but for a very, very small value of h. So as h approaches 0, you realize now the cosine of h approaches 1. And that is how And that is how the cosine of h, a very small angle, is 1. 1 minus 1, which is 0. 0 divided by anything is obviously 0. And that is how the whole of this part gave us 0. 0 times sine x, which is 0, plus cos x times 1, and the whole thing is supposed to be equals to the cosine of x. And that is the derivative of the function sine x. Again, I say, after we have found out the cosine of h, as h approaches 0 is approaching 1, this part, cosine h, for a very small value of h, is approaching 1. 1 minus 1 is 0. 0 over anything gives us 0. So the whole of this bracket gives us 0. 0 times whatever it is, it will maintain to be 0. And of course, 0 plus the cosine of x give us the cosine of x as the derivative of this original function. Well, this was just to explain how we got the solutions of example 1. Please visit my YouTube channel and subscribe and share widely, and let's work together. Thank you and welcome.